to you about Birmingham New Street stationary development works. So with webinars, we can't see or hear you. Hopefully you can hear us. If you have any questions, use the Q&A thing on the toolbar. So we're going to start off with a case study, a bit of a whistle-stop tour on Birmingham New Street, and then we're going to have a Q&A panel on temporary works. But before that, the obligatory little bit of spiel about Andun. So we're specialists in temporary works and demolition engineering, and we operate from 3 locations across the UK. And we love nothing more than solving engineering problems for people. So that's what we do. So we're going to have the following people. We're going to have Ray Phillip of RKF Consult, Malachy Ryan of Alan White Design, David Thomas of TWF, and Steve Williams of Network Rail. I think you can see 3 of those people perhaps at the moment, and Steve Williams is there, but he's on the phone. So those are the people we're going to have today to answer any of your questions. It's going to be a first for us, so it could get a bit messy with 5 of us trying to talk over each other, but please bear with us. We'll try and, or Christian will try and keep control of us anyway. So just while I'm going through this case study, have a little think in the back of your mind about questions you might want to ask of the people that are here. It's not very often you get a group of 4 or 5 people that you can ask pretty much anything you want related to temporary works. Please keep it related to temporary works, at least in the broad sense, if you can. There's a couple of questions I've put on the screen there that we are going to talk about already, but it's the sort of thing that the sort of question we're looking for is along those lines, is something that's maybe fairly broad reaching and you just want to discuss. It could be something on a specific project, it could be whatever you want, but just try and keep it related to temporary works. Now let's get going. Birmingham New Street. It's a while ago now, but it is quite an impressive project when you start digging in and looking at what was actually done and what was achieved on the scheme. The overall client was Network Rail and Birmingham City Council. The principal contractor on the scheme was Mace. The demolition contractor for most of it was Coleman and Company, although DSM did take down, I think it was Stevenson's Tower. Broadly speaking, there was 2 phases of works, which kind of aligned with the 2 phases of the project. The idea with the New Street station was that half the station would be reworked and then opened. That would then allow the other half of the station to be reworked and opened, and the whole thing was then combined. So it's quite an impressive project in terms of it was all achieved with the railway remaining open for most of the time. There was the odd possession of things, but pretty much running the railway as it was, and it's a fairly busy station to try and keep open, which was a key driver for a lot of the works. It was about £750 million project overall, and there was some 15,000 tonnes of concrete removed from the station during the course of the works. I'm going to give you a bit of a tour through a couple of bits, but in terms of what we did on the project, it was a nice meaty 5-year project. Most of it was, or a lot of the engineering was by my father, Neil Holdsworth. I joined him about a year into the project, but he was the brains behind a lot of the engineering you're about to see. So I can't take any credit for it. He was the man coming up with it. We worked on the demolition, we worked on the new build, with everything from the demo sequencing through to tower crane bases on the site, and there were an awful lot of Form C submissions. Form C is what we used to have before the Form 0203 system, and it won a World Demolition Awards, this scheme for Coleman and Company for the works at Birmingham New Street Station, which was a nice end to the project, or the first phase. So we're going to start off with the NCP car park removal. Now this is a little video that kind of sets the scene as to what was done and how it was done. And why is that not going full screen? That was supposed to go full screen, but for some reason it doesn't want to. Oh well. No. That is not what I wanted to do. Try again. Sorry about that. No, it's not going to go full screen. You'll have to make do with a little version, I'm afraid. So this is a few before shots of the station, and this is inside it. This is after quite a bit of the NCP has come out. You can see there one of the gantry cranes in operation. bobcat running around. There you go, you see the gantry cranes and the crane rails, and then the RMD trusses underneath it. So that's a big old RMD truss there supporting the beams as they were cut into blocks and then lifted out with the gantry cranes. That's one of the beams we actually had to cut free and then slide sideways, which is quite an interesting scheme. Some of the slabs coming out there. Temporary bracing to the structure where we'd removed the floor. Some of the little stubs being removed there that were left on once we finished the saw cutting of the main beams. And again, one of the big dirty trusses there supporting the blocks. And you can probably appreciate there's some serious engineering that went into this job to make this work. And there we go, once we'd finished it all, or once Coleman had finished it all. So we're going to have a little bit of a quick review of the site and what we did during the NCP phases. So the NCP is the old NCP car park. So I can't remember what NCP, National Car Parks, I guess. That was that level there within the old station that had to be removed. Now the floor below it, sorry, let me just put on my cursor. Oh no, not what I meant to do. There we go. No, not what I wanted. There, sorry, that's better. Tell you what, there we go, right. So this floor here, which was just above platform level, had a limited capacity for plant, which is why we had to come up with a scheme that allowed us to take out the whole car park level there without loading or overloading the floor beneath and endangering the railway, which is just down here. So this is a section through the site, which just puts it into a little bit of context. So the solution that Neil came up with was these gantry cranes. So this is now an isometric view of the station, or part of the station. And the red lines you can see there represent crane rails, and these yellow frames here are the gantry cranes. So the idea was we could put in the crane rails and these large cranes that would allow us to cut out the site, cut out sections of the concrete in around 10-ton lumps, and then translate it out the end of the building and onto the back of a lorry and away. So that was the plan at a fairly early stage. So if you're looking at a plan view of the site, you can see there was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 crane rails, I think. 2, 3, 4, 5, 10 crane rails, and that just allowed us to take the structure apart and then move it out the end. There were also some areas where we had to cut beams free and translate them across the site before they were cut up and then lifted out with the cranes. There was all sorts of things that went in. At the end of the station here, we had the crane rails continued out, and that's where the lorries could back in underneath here and then load up and go straight out. So looking at a end view, you can see the crane rails effectively sat on the mezzanine level. So the stubs of the beams that we were removing stuck out here and supported the crane rails themselves. So as part of our package, we were assessing the structural loads, plus designing the crane rails and the cranes themselves, designing the transporter system and assessing the structure for all the loads that were proposed. So these 3 bays here, where the lumps of concrete came out at the end, they went onto a transporter truck here, and then they were translated to the right hand side and then picked up again and loaded onto the back of the lorry. So I'm just going to clear my screen. So I've just realised there's some lines on it. There we go, right. You thought I'd be better at this by now, given it's about the 11th or 12th presentation I've given, but no such luck. So that is the transporter bogie itself. So see that gizmo there? That's it in reality, which again we designed and came up with a method for moving it along. It's even got a turntable on the top of it, so you can rotate the blocks and then pull them out the site as required. And then the cranes themselves. So you can see we've got some dirty grey crane rails that run the width of the station, and then the cranes themselves which ran on top of it. And you can see there the floor in this area has been removed, and these are just sitting on the stubs that stick out of the columns. Now, as I said, the driver for this was not loading the floor down here. So these trusses here span from column to column position, and put the load in very close to the column. The load from these beams here as they're cut into slices, thereby eliminating the massive loads that we would have had to place on the floor if we'd used traditional plant to do the demolition. And it cut down on vibration, dust, noise, etc., which made it a much more attractive scheme than any other that was available. And I think it's one of the reasons why Coleman's won the job to start with. It's just another view. So this is out towards the end of the station. Again, you can see the truss in place with a piece. That beam's already been cut into pieces there, ready to be lifted out bit by bit. And there's the stub that we talked about that remains in place. I'll talk later on about how we then get these stubs out when we're finished. But you can see that's the basic principle of how this job was done. And there's just another view looking at the truss system. You can see in this case, the truss has actually been extended past the columns to load pretty much directly on the centre line of the column. All various different methodologies that were used to deliver this project. There's one of the 10-ton lump of concrete up in the air from the crane. So it was quite an efficient way of getting these bits of concrete out of the site. Now, where we came out at the end of the site, at the end of the station, we had a bit of a problem with the structure here. So we ended up having to prop the pre-tension beams here. You can see the transporter running there, which ran along one of the main beams. And that allowed lorries to back right into the station and then load up. And this was the old taxi rank area here, which was rated for highways. And then this was strengthened to allow us to get the lorries in and out. There it is in action. One of the many lorries that was used to take concrete out. At an early stage, it was looked at to see if we could use rail transport to take the concrete out, but it wasn't really feasible, as I recall. I can't remember the exact reason why, but at an early stage, it wasn't feasible. Now, in some areas of the station, we had to pick up the beams and translate them across the site so we could pick it up with a crane. So again, we've got a proprietary truss system underneath here, and then we put these big crane beams, they were sections of the crane beams, and a skate system that allowed us to skate across the beam. So if the beam has been picked up here, that would allow it to be moved across to here, or wherever we needed it to then pick it up again. You'll recall that I've mentioned a few times now these little stubs that were left hanging out or sticking out the side of the columns. We need a little gizmo for picking these up, and this was one that Neil designed that clamps around it, and the action of applying a load here, so there, actually drives this clamp mechanism down into the block. So it's making it intrinsically safe. The harder you pull, or the more weight or load you place on the lift point, the more it grips onto the concrete block itself. So there you can see actually in reality the system in place using a little A-frame gantry that allowed us to pick the stubs up or hold the stubs, preload it and then cut it free, and away you went. Because the columns remained, but we had to cut the stubs back to pretty much flush. We were also responsible for, or one of the people responsible for, assessing the structure for stability purposes. Excuse me, my hay fever's playing a bit today. Now, I think Atkins were the lead designer on this at this stage, so they did their own assessment, but we also did an assessment of the stability of the structure and then designed a temporary restraint system. Obviously, if you're removing a floor out of a structure, it affects the stability. So we came up with a system that stabilised the structure as we saw it. The atrium works was the second stage of the works. Now, due to time constraints today, I'm not going to go through this in a great level of detail, but I'm going to show you a video of what was done. Now, if any of you remember going to New Street as it used to be, you'll remember it was quite a dark, dingy station, and it was always incredibly busy. I think that the number of passengers it was designed for compared to the number it was actually using it had doubled. So I think it was supposed to work for a footfall of about 15 million people a year, and you got about 30 million through the station. So it definitely needed some work doing on it. And I think it's the busiest station outside of London. So it needed some significant improvement works to make it fit for the future. So this is the atrium work itself. So when you come into the station now, this is what now makes it a nice light open concourse. Now, to do that, we had to take out quite a lot of the structure, and that was done after the new plastic roof, ETFE roof, had been put in place with a new steel frame to obviously try and keep the structure waterproof throughout the works, or as far as we possibly could. Now, this is another example of the sort of ingenuity and the lengths that Coleman and Company will go to. This is what we call the Mega Muncher. Now, this is a special bit of kit manufactured by JCB, specially for Coleman and Company. It's got the tracks of a 22-tonner, the body of a 15-tonner, I think, from memory, and then a different arm.
We seem to have lost Angus for a second there. So we'll just give a couple of seconds, hopefully, for that to rebound, as I don't have, as having me do the rest of this presentation wouldn't work. Steve, you were on this project. So
the first thing I could say is that the concourse that all this demolition work was done, this is the previous phase, not this phase, had the live railway directly below it, and most of that slab was actually a 4-inch slab, so there's virtually no load bearing capacity to take any of the stuff that was going on up there. So what was really clever about the design of the temporary works here was the way in which it allowed all of that deconstruction to happen whilst being only a few inches away from a live railway. And in addition, at the time, there was a live shopping centre above. So we've got all the live loads, we've got all the railway operations, and yet they devised a temporary work scheme that allowed both the stability of the building to be retained by means of all the temporary restraint, and get out many thousands, I'm not quite sure how many, but I think it was something in the region of 15,000 tons of concrete from the job. So it was quite a feat, bearing in mind that you've only got 4-inch slabs for most of that entire concourse, which is the size of half a football pitch. It's pretty mean feat. I think you're back now, Angus. Oh, still silent though. So yeah, it was a really interesting job. It happened over a number of years, and there was a great collaborative working amongst all parties to the job, which is a key takeaway really from that particular project.
Am I back in the room now? Can you
You're
hear me?
back in the room, giving me
what happened there, buddy. I was chatting away to myself, and then it started spinning on the screen. I was like, uh-oh. Right.
Yeah, so whilst you were gone, we just had Steve was just talking about some of the restrictions about having the shopping centre above, and giving an overview of some of the project. So fortunately this time we had someone else who was on the project, so I could hand over and go, take it away.
Does anyone know where I dropped out? What was I talking about when I dropped out?
I can't remember. I was too busy having a heart
attack. You were just talking about the Mega Muncher
Right, so the Mega Muncher itself was designed to be taken apart easily, because for the first phase of the works it had to be dismantled and then moved into the site and then put back together again before it could be put into operation, because we had this big roof over it, so it couldn't just be dropped in where it was needed. So that was quite an interesting little challenge in itself. So let's get this going now. There we go, it's working full screen now. Clearly something wrong with my computer earlier. So this is just a little time lapse of the atrium being taken out in September, November 2014. So this is what was the roof of the structure here, which was mostly taken out with brocks, taking out the slabs, but they couldn't handle the beams, or not efficiently anyway. If you're very quick, you can see the Mega Muncher being used here and there. If I can slow it down. There we go. Right, I'll slow it down a bit. There you go. You can actually see a lot of the work was done at night as well here. And we had to do the full assessment of the structure to demonstrate where it could work and prop it as required. It was quite an in-depth package of work, this one. You see some of the steel sections going in and around for propping and the like. And the navy mats down on the concrete deck to spread the load of the mega muncher. It was all fairly, well, it had to be very carefully controlled where it could go, what it could do. Unfortunately, it's an old video now, so it's not the... Oh, there we go. Let me try that again in a better quality. Actually be able to see something going on then. There we go. That's hopefully better. So this is the roof level coming out. You see some of the propping systems in underneath here, which were put in place to support the beams when the mega muncher then took them apart. See the spider cranes being used to assist with bits and pieces. And you can see the mega muncher coming in for the first time over here. We've got there what we called the Brassington beams because the man who came up with them. So we underslung a steel beam from the stubs at the end, and that supported the main beam itself while it was demolished, and prevented any large loadings ending up on the floor below. Because below this you had one more level than you had track level, two more levels in track, but you had live. It was a live station still, so that always was used to drive methodologies and thinking and risk assessments of how it was done and how things were to be done. I'll just speed it up a little bit, otherwise we're going to be here all day. Excuse me. There you go. There's a little bit of a view of what happened. This is just a bit more of an in-depth look on one aspect of one of the many temporary works packages that we delivered. This was the balcony out the front of the station. So I think from memory, this was the old taxi rank along here. Queen's Drive, if I'm right. Someone will probably correct me if I'm wrong. So the drive for this, we needed to take this balcony out, but the area below had to remain accessible for the public, etc. during the works, and there were many things below that meant we couldn't just prop it and do any sort of traditional demolition, and we couldn't really get a crane anywhere near to do cut and lift, and it would, because of the length of the balcony, it would have taken an awful lot of crane time or hook time to have achieved it with many crane setups. So we were asked to come up with a solution, which we did. So what we proposed was this this mobile deck. So steel grillage here, kentilage at the back, and then you have this steel frame here that you lift over onto it, and that sits underneath the balcony. That allows you to break out onto the deck, then clear it, then roll the whole system along. So there it is in operation. And in plan view, you've got a brock sitting on here, and then you've got the kentilage at the back, which keeps it stable and stops the weight of this frame on the front pulling it over the edge of the building. And then, all right, the station's slightly curved, so it wasn't just continuous rails, but it travelled along the length of the balcony and did the job it was supposed to do. So that's what you ended up with, and that's the reality there. So that's the frame that hangs over the edge of the structure. That's the frame on the deck. I think this is after it's finished, looking at the state of it. And there it is actually in place. So there's the frame that hangs off the deck up the top here. And you can see it projects back underneath and allows you to break out. And there it is in action with the Brock sitting on top, doing its thing. And that worked quite well, really. One last thing that sticks in my mind on this job was the Form C procedure. And this is, I think, where Steve Williams had a big part in it, was the use of what was called on the project the umbrella Form C. Now, a project of this size and magnitude, there was an awful lot of temporary works going on over the site, and there's a lot of potential areas where if we were doing some demolition, someone else might be loading the structure below, and it had to be coordinated to make sure that we weren't impacting each other without realising it. I think a lot of this later in the project they used 4D planning for, but the actual control and control of the temporary works was driven through this umbrella Form C. So you might produce, for instance, we might have done series of Form Cs for Coleman's on one area of the site. At the same time, we might be doing a couple of bits for Severfield and then Watson Steel. Now, we then have to produce what was called an umbrella Form C, which indicated to the Network Rail team and the Mace team how these three, or how these 7 schemes impacted each other, and making them aware of how they needed to be managed, which was quite an interesting system, and I think worked quite well. And I'm pretty sure Steve Williams might well have something to add on this when we get into the Q&A in a minute, but it's one thing that sticks in my mind. It was a good way of managing temporary works risk on a project. Want to know any more? These are the places to go. Been through it before. Temporary Works Forum is the place for temporary works, really. NFD